Here we're going to look at the assignment, evaporation activity assignment, where we'll use this animation environment to answer these questions. These questions here look at two different liquids. One liquid has weak intermolecular forces, the forces that bind the liquid molecules to themselves, and the other liquid has strong intermolecular forces. And for each one, we can vary the temperature from colder, warmer to warmest, and look at how the vapor pressure is influenced by weak to strong, and for a given intermolecular force, how the vapor pressure is influenced by the temperature. And so we'll use this environment, Control-click to get over here, and start with weak intermolecular forces here, weak temperature or lowest temperature, and then go ahead and click the Start button. And it takes about 40 seconds, 45 seconds for the vapor molecules to equilibrate. That is, you reach equilibrium or saturation, a constant number of water molecules in this space above, when the evaporation rate equals the condensation rate. And after we get to that point, the animation ends and the vapor pressure and temperature are given here. Okay. Again, the normal unit of water vapor pressure is the millibar. If the water vapor pressure is large, that means we have a lot of actual water in the air, or the actual humidity of the air is quite large. Okay, in this case, what we'll want to record is a vapor pressure of 0.901 and a temperature of 608.1. Now, when you do this activity, make sure you do all 6 experiments, 3 temperatures, for 2 different intermolecular forces, all at one sitting. If I went and restarted this again, I'm going to get different results, and the results aren't going to be consistent with what I would expect. So make sure you do all 6 runs in one sitting. Okay, going back to the activity here, there's some questions that you can answer right here. This is a Microsoft Word document, so you can answer the questions right in the document, and then save this and submit this. Let me give you a little bit of a hint on question 4. This has been one that's bugged people quite a bit. Here we've got 4 different intermolecular forces, from very weak, weak, strong to very strong, and 4 different temperatures, T0, T1, T2, T3, and T4. T4 being the hottest and T0 being the coldest. And this information here is just provided to break ties, so that you know that if you have a very weak cold temperature, that's going to be the same vapor pressure as a weak hot temperature. And this information here is only to break ties. I'm not sure if you actually need to have that, but just in case. And let me just give you a hint. Of all of these here, which would represent the very lowest vapor pressure? Well, that would be the one that would be coldest with the strongest intermolecular binding force. So a very strong and cold, this would be our number 1. Okay, and then the other extreme, the highest vapor pressure would be a very weak and hot temperature. And I think all of you can see that that would be number D. So I'll let you guys fill in the rest on that one. But this gives you a good start and explains what we're looking for in that. Is we're looking for a rank order of how these things play out from the smallest amount of vapor pressure very strong cold, to the largest amount of vapor pressure, very weak warm.